Okay, so here we go. I already talked about these first two. I forgot to record for the first group. Okay. So 3, here we go. We got x is greater than -2, less than -3, I have x plus 4. I wrote this system the way I did because I wanted your points of intersection to be very clear. So if you go from 4 and go down 3/2, down 3/2, you run into an intersection point. And if you go up 3/2, you run into an intersection point. If you do this other one correctly, my x-intercept to be 8 and my y-intercept to be -4, then you get nice intersection points. So the ones you're checking are 4, -2, -2, -5, -2, 7, and you get maximum of 8. It occurs at 2 different places, and then you get a minimum at -16. It occurs at -2, -5. Okay. 4. Here's the problem that some of you guys are running into with 4. This is the equation. I'm going to put OA here so you can see what's going on. This is the equation that I'd say, the most commonly missed equation was this, if people missed it. This is what people wrote. That I want 5 pounds of oats, 3 pounds of flour, which I agree with that you want 5 pounds of oats and 3 pounds of flour. But that's for A. You can't say that 5 pounds of oats and 3 pounds of flour equals 180 pounds of oats. So your equations need to be oats, 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 flour, 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 money, money, money. Okay? So that's where I'm getting mine from. The A mix uses 5 pounds of oats. The B mix uses 2 pounds of oats. And there's 180 pounds of oats. This is 3 pounds of flour for A, 3 pounds of flour for B, and there's 135 pounds of flour. Flour, 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 oats, oats, oats. So your units need to be the same. They need to be saying something that makes all the same units and kind of makes sense with that. And then as we're graphing this again, if I go ahead and find on my first equation, my A-intercept, 180 divided by 5 is 36. So my A-intercept would be 36. If I plug in 0 for A, my B-intercept, 180 divided by 2, is 90. And then connect them. And then go on to your next one. 45 and 45, connect those. Okay? So again, you got to be able to solve using intercepts. And the thing is, the problem that people are running into is if you have a problem on Monday, something you can't do on Monday, and then you can't do it on Tuesday and you can't do it on Wednesday, then it just keeps getting worse and worse. You can just get buried under this avalanche of stuff that you can't do. And then you try and really start trying hard, and then you're just fighting stuff that it's all just piled up on you. So kind of the lesson in life in general, when something is going wrong, fix it straight away. Get it. I mean, even with my wife, I try and if we're not getting along with something, I'm like, okay, what's going on? And then she says, you know what's wrong. No, I'm just joking. We communicate really well. How long do you think we've been married as of tomorrow? 50? No, I haven't been married since I was 10. No, 6. 33. Very close guess. Good. We've done pretty well. I haven't had too many rough spots, but sometimes things are awesome. Other times things are just like ho hum. Sometimes we disagree on some things, but we work it out and we go from there. My wife's a stud. That's the most important decision you can make in your life is who you marry. Absolutely, hands down. So I did good. Okay. She outkicked her coverage, but no, I'm just joking. I probably did. Anyway, so if you plug in your points, I need to see that you're plugging in these 4 points, and then you get 1650. If this point was a little bit off, like say you had 30, 17, I wasn't going to be super picky about that, okay? But I wanted to see that you were plugging in values into your objective function. It says, write an objective function. And then go from there. Okay. So 5, I'm not going to take a lot of time talking about 5 because on every single one of yours, I found your mistakes. This took me, I'm not looking for any sympathy, I'm just telling you it took me about 3 hours to grade this. Just because I was finding everybody's mistakes. Okay? And it takes a while to find mistakes. And I know it can get frustrating for you. But anyway, my advice, stay organized. Stay organized. Okay? The more organized you are, then the better off you'll be. The only thing I have a big problem with is when people on the test don't have an idea of the theory. We want to go from 3 equations down to 2, 3 variables down to 2 variables, and then we can work with that the way we've done in the past. If your answers don't match your work, of course, I'm not going to give you credit for that. I need to see that your work leads to your answers. I just think that's reasonable. 6, your equation is all about cost. Okay? And some of you took the hard way to the final answer. I want to show you the easy way. This right here, this 2h plus 3p equals 9, that's a gift. Why do I say an equation like that is a gift? Because it's already down to 2 variables. If I'm already down to 2 variables, then my job is super easy. Why are you laughing, Zach? Because you didn't see that? You did your stuff the hard way. You got rid of h, didn't you? Yeah. Okay. And you can do that. It's just you went around the block to go in. Okay? So anyway, so what I chose to do was, since this one doesn't have an A, I got rid of A. And then I combined my 2 equations. For those of you that are uber organized, thank you. Okay? Those that aren't, that's going to bite you in the butt later on. So work on getting organized, please. That'll help you. Okay? And then I just go ahead and solve it and go from there. But here, I got my 2 important points. I got this, 2 important equations. Now I need to get rid of something else. I decided to get rid of p. So I multiplied this by 3. Okay. Bonus A. Bonus A works really pretty nice. It's a little bit cumbersome, but it's not as hard as you might think. If you just solve these 2, add down, m is 5, plug back in, n is 2. Plug those back in, you find out that z is 1, negative 1. Plug those back into the next one, you find out that y is 6. And then you plug those back in and you find out that x is 3. Okay? So, bonus B, I threw an extra one in there from when I first wrote it. 0, 1. The way you get your next term is to add the 2 previous. 0 plus 1 gives me 1. 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. So 5 plus 8 gives me 13. 8 plus 13 gives me 21. Has anybody ever seen that series of numbers before? Really? Where have you guys seen it? Mrs. Bowens? Great. Okay. Good. Because this is actually a very, very, very famous series of numbers. It's called the Fibonacci sequence. Did that sound familiar? Yes. Fibonacci sequence. Fibonacci sequence is actually very famous, found in nature a lot. Large majority of your species of flowers, the number of spirals they have in their seed pods is a Fibonacci number. The number of petals is usually a Fibonacci number. The way that trees grow, there's Fibonacci ratios in there. If you look at the old buildings that the Greek and Romans built, they used the Fibonacci sequence to size things in a way that they thought was beautiful. Okay? They had this theory that, this rectangle, that's an ugly rectangle. But if you have the proportions, say, of 5 and 8, then that makes a beautiful rectangle. And they used the Fibonacci numbers and what's called the golden ratio in building their things. And actually, there's some evidence that the Fibonacci sequence and the golden ratio is also found in the human body over and over and over and over again. It's kind of interesting. Okay. In 10 years. Okay? I did not fill this in because I think it's pretty obvious. What's the thing that I hope for in 10 years? That I'll be retired. That's probably true. And that I'm still alive. Okay? Because at my age, I'm getting into my drop-dead years, where it's like, what happened? Oh, he just dropped dead one day. Or, anyway. I'm hoping that's not the case. I've got good 56. Did you think I was older than that, Holly? No. Or younger? Think carefully before you answer that question.
I knew that you were in your 50s because you called my dad, but that's why.
What was your dad's name?
Ross.
Find me a
picture of him in high school?
Yeah, or just a picture recently, because
he does not look anything like that. Oh, yeah, I have a picture. I'll show you.
Okay, interesting. Okay, anyway, so let's have a serious talk, though. Honestly, I want you guys to have big dreams. That's true. But make sure that your discipline and your approach to your studies matches what your dreams are. Okay? I've got some students where their dreams are here and their discipline and their approach to their studies match what they want to do. That's great. But I'll be honest, in some of the answers that I saw a lot of this, where people want big things and their seriousness and discipline isn't quite to where it needs to be to accomplish those things yet. So, but you can get there, okay? So, because you have to be able to handle stress, apply yourself, and this, that, and the other to be able to do great things, okay? So, anyway, that's my little advice to you. Big things don't just happen. You make them happen. So here we go. The retake deadline for that is by next Thursday. Only a dream job? But what is your dream job? Okay, well.
Because I don't tell anyone.
Okay. Okay, so here we go. Whiteboards. Oh, no, we got to do assignments yet. So let's take a look at our assignments. I'm sorry. Is that good? Okay. I have turkey today. Okay, so here we go. 4. 4 needs to look like this. It's centered at the origin, and it's going down. Okay. So it's going down, and it's an over 1, down 2, over 1, down 6. If you don't want to use the over and down and over and up and stuff like that, then you need to have a table of values. Okay? 15. Where's 15? 15, 15. If you're not getting these right, write it down, and we'll see if you can figure out why they're not right. I'm not going to show them up here because they're way too small. 15 is -3. 18 is 36. No, I'm just joking. It's just seeing if people were going to write down the right answer. 18, the answer is 8. Okay? If it's wrong, write it. If you're getting it wrong, write it down. Figure it out. 21 is 7. Okay, now I'm joking. No, 21 is 3. Okay? Okay.
No, I'm joking because you're making me so confused.
No. Okay, so here we go. Let's start again. 15 is negative 3. 18 is 8. 21 is 3. 24 is negative 4.
15 was what?
15 was negative 3. 25, you get 2.476. Okay, but what does that mean? That's in millions. You have 2.5 million people, million more people in this last year are eating between 8 and 11 bags of chips. But I wasn't quite sure on this one. Are they the small bags or the big bags? Or what do you... Well, in a year, though, if you eat 11, that'd be like 1 bag of chips a month.
But do you eat chips a lot? That's like the thing.
We eat potato chips fairly often. Yeah, in our just for supper and stuff. Well, more for lunch, stuff. Or if we're having hamburgers, we'll just do chips, instead of fries or something. Anyway, what? Yeah, probably so. Okay, so here we go. 26. I got to find my answers here in this. Okay, here we go. 26. 26. 0.51. So what does that mean? That's per 10,000. So if you take 0.51 times 10,000, that means there's $5,100 more, a $5,100 increase in that year. Okay, or in those years. 27, let me show you some answers here. 27 is going to look like this. Y-intercept's negative 9. Axis of symmetry is x equals 1.5. The rest of the vertex is negative 13.5. And the graph looks something like this. Okay. 30. Y-intercept is 0. Axis of symmetry is negative 2.75. And my vertex is negative 15.125. Down. And then it goes from there. 30, 35, 35, 35, 35. Where's 35? This book is awful. I know. It's just, I got some answers here, and some answers here in this book. It's nuts. 35, it has a maximum. And the maximum occurs at 1.4. And that maximum is a y value of 3.8. 38, it has a maximum, and the maximum occurs at x value of negative 0.75, and the maximum value is negative 9.25. Maximums are really important. Minimums are really important. 38, last one. Oh, I just did. Okay. Okay, so we do have time for questions. If you have any of those that you want me to go back and take a look at and figure out why you maybe got the rate of change wrong or something. What? 30, you betcha. Look at this, somebody asking a question. What a deal. Awesome, awesome. So for 30, I've had a question asked on 30. So f of x equals 2x squared plus 11x. So what we're looking for on 30 is find the y-intercept, 0. It says the equation of the axis of symmetry. Well, it's an opposite of b over 2a. Negative 2.75. And then if we take that and plug it back in, we get that answer, which I'm not going to take the time to, negative 15.125. Okay. Why did I put that in parentheses? Okay. So the graph, I don't know if I'm going to take the time to find graph paper on this one, but I'll just tell you, if we're down here, after our first point, since it's a times 2, everything's going to be twice as steep. So we're going to go out 1, up 2, out 1, up 2. And then out 1, up 6, out 1, up 6. So then that's kind of where our graph is going to come from. Okay. So without graph paper, it's hard to get real accurate with that. Did you find it?
Yeah.
Good.
The graph wasn't reaching 0.
Mm.
Yeah, but I moved it over to the right one.
Got it. Got it. Okay. Yep. Okay. Whiteboards, please. So here we go. I need to decide whether or not you can, or what kind of level of retention you have, how well you can do a skill before I really move on. Okay? So in this particular case, the skill is simplifying the square root of 20. Okay? If I know how well you can do that, I will know how, if I've got to start from scratch or what method you guys use. So I want to see if you guys can simplify the square root of 20. If not, then that's fine. You can just relax, but do what you can and show me what you can do here. Thank you. Thank you. Molly, who was your Algebra 1 teacher? Who was your Algebra 1 teacher? Mrs. Boland? Mr. Rogge? Okay. Okay, but what's your answer? Well, how is it simple? Okay. 10 times 5 doesn't give me 20. You're close. Okay?
So is it the other way around?
I think so. Okay. So here's the deal. Okay. It's one of those two. Good. Okay, so here we go. I'm going to review how your previous teacher did it, and then I'm going to show you how I like to do it. And it's kind of more of there's a lower level way to do it, and then how you might want to do it when you work later on. So this one, here's what you did. 2 and 10. 2 and 5. And you can find that prime factorization a couple different ways. If it's square roots, you're looking for a pair of things, right? So this pair of things, what were you guys told after that?
You put the 2 on the outside.
Put the 2 on the outside and the 5 on the inside. Do you know why you put the 2 on the outside?
It's a pair?
Because it's a pair, but why, if it's a pair, can you put it on the outside? Okay. So this is the reason why we can do that is because 2 times 2 is 4. What's the square root of 4? 2. That's why. Okay? So yes, 2 square roots of 5 is the proper thing to do. I'm going to show you how I will do it. I keep in mind my special list of numbers. 4, 9, 16, 25, 36, yada, yada, yada. What's special about those numbers? They're all perfect squares. And I know the square roots of them. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Those are the numbers that are special, that are worth looking for. Okay? So here's how I'll do the square root of 20. I'll say, 20 has a special number that goes into it, 4. And I can rewrite 20 as 4 times 5. We all agree that 20 is 4 times 5, right? Well, what's the square root of 4? 2. So I know that. I don't have to square root that anymore. I just did. And I'm left with the 5 that I can't square root. Okay? You can do it however you want. But that's just how I do it, and you'll see maybe why that's how I do it later on. Here we go. Let's try another one. Square root of 75, please. Go. I don't care how you do it.
Oh, what the heck?
Good. But just be careful. Don't put the 5 on that in that little crotch there. Put it next to it. Because yes, otherwise it looks like the 5th root of 3. Great. Perfect. Awesome. Great. Inside. Oh, you didn't. What's 5 times 25? Okay. Good. Okay. Good. Okay. 5, 15. No, 5 and 15. Yeah, that's right. 3 and 5, 5, 5. So you're sticking with the throw it outside and what you have left over. Here's what I'm doing. 25 and 3. 5 squared to 3. Okay. Okay. So, here's new information. Whiteboards. I'll tell you what, go ahead and put your whiteboards away. Thank you for letting me see what you can do and how you do it. Excuse me. Got the yawns. Ooh, the little blue light on my microphone matches my shirt today. I'm so excited. Okay. 3.3. I'm going to go through this I'm not going to do a deep conceptual dive on this. I'm going to give you the skills to just enough to do some basic work with this. Okay? So, personally, I like complex numbers. It's just an upper level thing. After you know this, all the younger people younger than you that haven't taken Algebra 2, you'll know something that they've never seen before. What's the square root of 9?
3.
Why? Because 3 times 3, which is 3 squared, equals 9. Good. What's the square root of 4? 2. Why? 2 times 2, which is 2 squared, gives me 4. Okay. I'm going to give you a new number. The square root of negative 1. The square root of negative 1. Here's the thing. Most of you guys, and rightfully so, are probably saying, I can't find the square root of a negative. I can't do that. What'd you say? I. How did you know it's I? Have you heard that before? Good. I'm impressed. Okay? It is I. Okay? So I'll ask you a couple questions about I. Is I a positive number? No, it can't be positive, because if it was positive times positive, I'd get a positive 1 underneath. Is it negative? No, if it was negative, I'd take it times itself, and I'd get positive number underneath. So I is a number that is not positive, it's not negative, it is what it's called imaginary. Why do we do this? Well, because in some areas of mathematics, like if you're working with electricity, for example, they use I to represent impedance and capacitance and stuff like that. Then you need to know what an I is. Okay? You have to be able to square root negatives in some sciences. So why is this true? Because I times I, which is I squared, is negative 1. So there's a couple critical things we're going to do today. Square root of negative 1 is I. And I squared is negative 1. Those are two things you've just got to accept. I've got a robot chicken video that I'll show you tomorrow maybe that is perfect for this. Yeah, but it might be blocked. You guys have to help me through that. I'm sure you can help me get that played in here, can't you, Owen? Can't you, Chase? Play blocked things on YouTube? Most likely. Okay. I'm sure you guys have your strategies. Okay, so we'll do that tomorrow. Okay. But shh, don't tell the administration. Okay. So anyway, so that's one thing that's going to become very important. So now what we can do is to this list of numbers, I can add negative 1. I now know that negative 1 is something I can square root. So what are we going to do? Example. If I do instead the square root of negative 20, okay, here's what, if you're doing the factor tree, which I don't do, you're going to go negative 1 and 20, and then do your same things you've done before. Okay. And the 2 we're going to have outside. And the square root of negative 1 is I. And then we're going to have square root of 5. Okay. But that's not the way I'm going to do it. I'm going to go like this. Square root of 4. Square root of negative 1 and square root of 5. I just listed all the things I know the square root of until I had something left over that I don't know the square root of. So what's square root of 4? 2. What's square root of negative 1? I. And then square root of 5. 2i squared is 5. Okay? So let's try one. Square root of negative 40. Go. Just try it. I know we don't have whiteboards anymore. After you're done, look up, and if you got it right, go, yeah. Yeah. What are the factors of 10? So there's no pair of 2s. There's no pair of 5s. I don't know the square root of 2. I don't know the square root of 5. So we just have to leave it. That's a good point. I'm glad you said something. But 10, square root of 10, I can't break down because it doesn't have any perfect squares that go into it. I probably should have done an example of that earlier. Because if I do this, 2 and 5, there's no pairs.
I thought there was something you did with the 2 out and 2 from there.
Nope. Nope. So we get 2i squared is 10. Okay. So that'll get you through the first 6 problems. But then there's another thing I'm going to ask you to do. A complex number has a real part and an imaginary part. This is complex. It's got a real part and an imaginary part. If I add another complex number that has a real part and an imaginary part, I can add those together. So the way you do this is you add your real parts together, and you add your imaginary parts together, and then you have your sum. So what's my real part? 7. 3 plus 4 gives me 7. What's my imaginary part? I. So plus I. Good. So I would like you to be able to add 2 complex numbers. What do you think might be coming next? How to... Not graph. Oh, we can graph them, which is really cool. We're going to subtract. So if I go 5 plus 2i minus 6 minus 4i. Okay. Here's my recommendation. I would just take this negative and let's distribute it. Add the opposite, like you guys have added the opposite with your integers forever. So you get 5 plus 2i minus 6 plus 4i. So what do we get? Negative 1 plus 6i. Okay? So these i's are kind of weird, but I'm hoping that after you work with i's for a while, you'll start to see how it works. I don't like it when my pupils sigh at my jokes. Pupils, get it? Pupils. Hey, no need to lash out at me. Get it? Eyelash. If you follow along, I think you can just have a ball. An eyeball. I got a lot of those in there, didn't I? I'm just trying to. It's my attempt at some highbrow humor. I know all those jokes. They were kind of corny. That's all I got.
Yeah, where do you find these at?
I feel like you looked these up.
No,
They come to his mind actually.
no, that's all just stuff that I've developed over my 32 years of
32 years old.
teaching eyes. I should have been an ophthalmologist. Ophthalmologist, they work on eyes. I need to find some more, don't I? Or it's actually aqueous humor. The stuff that's inside your eyeball is called the aqueous humor.
What's your actual kind of news?
Yeah. Just put them on a different desk. Okay, I'm going to look up some more here. Okay.